Today I'm here to explain about this question. Find the vertical asymptote for each rational function. In the last video, I explained about horizontal asymptote. So if you have no idea about it, please check out my previous video first. Okay? So let's get started. What is vertical asymptote? I give you one example. Vertical asymptote is the horizontally vertical line which the graph is getting close to, but it never touches or crosses. This is the vertical asymptote. But how do you find it? So let's work on number 1 first. Y equal 2 plus x over x negative 3. What you have to do to find vertical asymptote is so simple. What you have to do is you have to find the x value to make the denominator 0, which is x negative 3 is equivalent to 0, which is x equals 3. Why you have to do that? Because denominator cannot be 0 in mathematics. You can't calculate something over 0. It's never calculated. And this means, and also this function is continuous. Continuous means it's like this. It's not like this. It's like the graph is continuing. It never stops. It never bounces. Yeah. So if this doesn't have the value of x value of 3, this means the graph is going to be like this or like that. It's never been like this. So this means if there's x value to make denominator 0, this is vertical asymptote. Okay? So let's work on number 2. So I will do the same way as number 1. The denominator is x plus 2, and x plus 2 cannot be 0. So let's find the value to make denominator 0, which is x is equivalent to negative 2. This is vertical asymptote. Let's work on one more question. Number 3, y equal x squared plus 2x over x squared negative x negative 6. You can simply do the same thing, probably. X squared negative x negative 6 is equivalent to 0. You can just factor it. X negative 3 times x plus 2 is equivalent to 0. So x cannot be. So the horizontal asymptote is x equals 3 and x equals negative 3. This is so tricky, but it's not the right answer. You know why? Please just look at this function. Actually, you can factor the top of the function as well, which is x times x plus 2. Or actually factor the bottom part, which is x negative 3 times x plus 2. Actually, you can cancel x plus 2. So this function is actually x over x negative 3. These are the restriction of the graph, but actual function is this. This means this x equal negative 2 is not vertical asymptote. Only this one. X equals 3 is the vertical asymptote. Okay? It's a bit tricky, but you have to be careful. First, you have to make sure if you can't cancel out the function anymore. Like this, number 1 and number 2, you can't cancel out anymore. Then you can find x value to make denominator 0. Okay? So you have to be careful a little bit in this case. That's all.